Welcome back to the classroom. My name is Mr. Wong. We're going to go through the 2015 HSC Physics paper. This is covering Module 5, Inquiry Question 3. So this is question 26, worth 6 marks. Consider the following two models used to calculate the work done to a 300 kg satellite at an altitude of 200 kilometers. You may assume that the calculations are correct. So you can see sort of the variations we have here. It says, what assumptions are made about Earth's gravitational field in models X and Y that lead to the different results? Well, for model X, so model X assumes that the gravitational acceleration is constant, while as model Y assumes that G varies or changes with the area of separation. So that's one assumption. The second assumption we could say is also the zero ground state. So model X, the zero state is from the surface of the Earth let's just make sure I made the right assumption. Yep, so it's made from the surface of the Earth, while as model Y, the zero state or the distance is measured from the center of Earth to the orbital height. We might change what we wrote for model X here. So instead of saying the zero state, we're just going to talk about it in terms of the height. Okay, so calculation only includes height of orbit rather than from the center of the Earth's distance. Why do models X and Y produce results that, although different, are close in value? Okay, so why would that be the case? Well, effectively speaking, they're both measuring gravitational potential. The only real difference that we have here is because, well, firstly, the heights are relatively similar. Okay, or the heights are different, slightly different. But the reason why it works is because both models go into the concept that it's the work done to move one object from one position to another. So the actual logic behind them are actually similar. They actually use the same logic. It's just expressed differently to each other. The other way of putting it is at 200 kilometers, any variation in G isn't very large. So that is also the case here. Obviously, the height difference should be accounted for when we do the calculations, but G, the value of G, shouldn't vary that much. Okay, so G does not or doesn't vary by a lot from an altitude of 200 kilometers. Okay, and then we go to C. It says calculate the orbital velocity of the satellite in a circular orbit at altitude of 200 kilometers. So orbital velocity, the formula is v equals to the square root of gm over r. The gravitational constant we already know. We also know the mass of Earth. Let's just make sure the mass of Earth is consistent. So mass of Earth at 6. Okay, so we'll use the number that's provided to us at 6 to the power of 24. We have the radius of the Earth, 6 to the power of 30. So 6.38 10 to the power of 6. I'm just gonna neaten this up. That's 6. Okay, so let's have a look at what the value is. So we have a velocity, if we round it off to a whole number, it's about 7,920 meters per second. That's the orbital velocity. And that concludes our explanation for this paper. If you found it useful, give it a like. If you found it useful, subscribe if you haven't done so already. And I'll see you next time.